we find the sine of negative 5 pi over 4? First, what you have to do. Draw a picture, whether you do that by going negative or adding 2 pi and getting the positive value. Either way is great. Did you all end up in the second quadrant? Okay. If you just count, which with radians, it's a little easier to do that than with degrees. And it keeps you from having to add 2 pi. This is negative 4 pi over 4, right? 1 pi, negative 4 pi over 4. We're going 1 more pi over 4 than that. So negative 5 pi over 4 is in the second quadrant. Since it's over 4, what is the
45.
So it's a 45-degree reference. So I've got a 1, 1 radical 2, except that one is negative. And so sine would be 1 over radical 2. Radical 2. Any questions about that? If theta is in quadrant 3, is sine positive or negative? So you're in quadrant 3. Why would sine be negative? Hypotenuse is always positive, opposite is negative. So opposite over hypotenuse, negative over hypotenuse. Any questions about that one? What about tangent in quadrant 4? Also negative. Tangent is opposite over adjacent. This is positive. This is negative. So opposite over adjacent would be a negative divided by a positive, which is a negative value. Any questions about that? Which brings us to wanting to know the sines of all 3 trig functions in any of the quadrants. We really want to know all 6, but I would say if we know 3, we can get the others pretty easy. Do you need to explain something? No. Really? Someone else probably has the same question. Does he really have it now?
I'm not sure. I can explain this.
What's his question? What's his question?
No, he's not good. I'm sorry.
Charlie, what's his question?
He drew it out. He's confused about the negatives. So you're doing negatives.
Okay. So, if this is a point, a coordinate plane up here, this is the x value to y value. And so I'm in the second quadrant, x value to the left, and that's negative. Does that make sense? And so up is positive, and right is positive, left is negative. That makes sense. Alright, now let's talk about the sines of all 3 of them in any quadrant. If I know these 3, the sines of secant, would you agree, would be the same as cosine? Cosecant would be the same as sine, and cotangent would be the same as tangent because a reciprocal doesn't change the sign, despite what you think from perpendicular lines, right? Perpendicular lines are opposite and reciprocal, that's why the sign changes. But just reciprocal just flips, right? So the sign won't change. So if sine is related to the y value, so this will kind of help anyway, because this summarizes all of it. Sine is the y value over the radius, right? When is y positive? Up. Okay. Because it's related to the y value. Cosine is related to the x value. And so when is x positive? Positive to the right, negative to the left. Correct? So these charts have worked for cosecant and for secant. We will do an extension to this chart tomorrow. This is the way I learned the signs of sine, cosine, and tangent. There's another way when we learn what's called the unit circle, which also works anyways. Tangent, we have to think a little bit harder because it's y In quadrant 1, they're both positive, right? In quadrant 2,
one positive, one negative.
and so when we divide a positive by a negative or vice versa, we get negative. What about quadrant 3? They're both negative, right? And what happens when you divide two negatives?
Well,
So that is the sign chart for tangent. Cotangent works the same as tangent. Any questions about that? A memorization tool for that is all students take calculus. All three trig functions are positive in quadrant 1. Sine is the only one that's positive in quadrant 2. Tangent is the only one that's positive in quadrant 3. And cosine is the only one that's positive in quadrant 4. So all students take calculus is kind of a summary of those three charts. Any questions about that? Now to get secant, cosecant, cotangent, you just have to think of it in terms of its reciprocal. Any questions? So, this is where this could come in handy. If tangent of theta is negative 5/12, then find the other 6 trig functions given that sine is greater than 0. Would you agree there are only so many ways that sine can be positive and tangent can be negative? Which quadrant do I have to be in if sine is positive and tangent is negative? Second quadrant, everyone agree? Okay, let's walk through how we know that. Sine is positive. Sine is positive in quadrants 1 and 2, right? So we know it's in quadrant 1 or 2. Which one of those two quadrants is tangent negative? Quadrant 2. I'm going to stall there because I always lose a couple people there. Anyone not know how I got that?
Not.
Okay, so I know that if I look back at those charts, sine is positive in the top 2. And so sine is greater than 0, so I'm in one of those two. But then I want tangent to be negative. Well, tangent is negative here and here. So I want both of those cases to happen, so the only way that happens is next one. That makes sense. It tells me to find these 6 other trig functions. How in the world am I going to do that? What is tangent? Opposite over adjacent. Which one of those is negative? The 12. Now it looks up there like it's a 5, but negative 5/12 is the same either way, right? And how do I know it's a 12 that's negative?
It's going backwards.
It's going left, it has to be. Can I find the 6 other trig functions? What do I do before I do that? How many? Does anyone know what it is without doing Pythagorean theorem?
13.8.
It's 13. You do Pythagorean theorem? You know the Pythagorean triples? Those of you who have very high ACT scores and would like to notch your ACT score just up a little bit, knowing those Pythagorean triples can do that. Google Pythagorean triples. It'll bring them up. Almost all of the Pythagorean theorem problems on the ACT are Pythagorean triples. 3, 4, 5, 5, 12, 13. And so you don't have to do Pythagorean theorem at all because you can just see them.
How did Michael know? You said he didn't know.
You've seen it before, maybe? Yeah. So there are some Pythagorean theorem problems that show up a lot. Google Pythagorean triples before you take the next ACT. They'll save you some time on the ACT. Just memorize a few of them. The biggest side's always the hypotenuse. And then those Pythagorean triples can give you the sides of 3, 4, 5. You'll probably need 3, 4, 5. And then 5, 12, 13 for that one. Just look the rest up. There's a few. Okay. And so I want to find the other, it says other 6, really there's other 5. Bad word. So cotangent, I didn't have to draw anything to find cotangent. I could have found that just from the original problem. If that's all it asks for, don't waste your time drawing a picture. I just flip it. are we in? What does this mean? Cosecant is negative, and what does cosecant go with? Sine, so negative down, right? So we're either in one of those two quadrants. But cosine is positive, which means I am in the fourth quadrant. Does everyone see how I did that? We are in the fourth quadrant. There are two ways to work this, and I want to show you both. How many of you just knew what kind of angle it was because we've done enough of these? What kind of angle is it? 45, 45, 90. Did you mark it 1, 1, radical 2? Okay. That's the easier way to work this. If you notice that, then yes, 1, negative 1, radical 2. Work the 6 trig functions. How many of you didn't notice that? Okay. Did you work it the other way though? Plus the other way. The cosine is radical 2 over 2. That means adjacent is radical 2 and hypotenuse is 2. If you do the Pythagorean theorem, you get radical 2 on that side. It would be negative because it's cosine. Will those give you the same answers when we do the ratios?
Yes.
Yes, because they're both 45, 45, 90 primes, right? So it doesn't matter which way you do it. This way, you'll have to do a little more simplification, but it gives you the same answer. Does that make sense? This one. If you do that Pythagorean theorem, you would get radical 2 squared plus b squared equals 2 squared. That makes sense. So, what are the other trig functions? Secant is the reciprocal, so 2 over radical 2. If you rationalize that, you do just get radical 2. Am I going too fast? Sure. Yeah. Alright. Sine would be negative radical 2 over 2. Either way, either triangle would give you that. Cosecant would give you negative 2. If you use this triangle, you'd have to do some simplification to get there. If you use the other triangle, that's just where we either way works great. Tangent is negative 1. Cotangent is also negative 1. Questions about that? Those are the same ratios you get for any 45, 45, 90 triangle. Just might be different on the sign. So, just a mental note. If I knew all of those 6 trig ratios, could I say I got 45, 45, 90 in quadrant 2? Could I just go through and change the signs appropriately? The sine would have to be positive, cosine would have to be negative, tangent would have to be negative. Does everyone see what I mean by that? And note that those ratios are the